Did she say that? I just like speaking Spanish every now and then because my wife is Hispanic.
She is?
Mm-hmm. Yeah, she's the whitest Hispanic you'll ever meet. All right, lesson 4-3. So we are solving equations by adding or subtracting. I'm recording, right? Yeah, okay. So we have an equation, solution, solving the equation, inverse operation, and equivalent equation. All right, so first off, an equation. So that's a mathematical sequence that contains an equal sign showing that two expressions are equal. Is called an equation. Okay, so that's when you have two things that are set equal. So a value for the variable that makes an equation true is called a solution. So that's the solution when you show that it's equal. Okay, so an example here is we have 120 plus x equals 168. Yeah, Courtney? Yes. 120 plus x equals 168. Okay, so we need to figure out what x is. So so right here, this is my equation. This is my equation, EQ. So now I need to solve for my x. So I'm going to subtract by 120 to both sides to solve for that x. My 120 is gone. I am left with x on the left side of my equation, which equals 168 minus 120. That's going to be 48. So x equals 48 is going to be my solution. That's my solution. Okay, so there's the solution. The equation is what you're given at the beginning. Okay, now, so solving the equation, okay, that's what we just did. So this whole process, we just solved the equation. Inverse operation. So you can use inverse operations to solve an equation. So inverse operations, they undo each other. For example, to undo subtraction of 5 in the equation y minus 5 equals 10, you could add 5 to each side of the equation. So that's what we did right here in this. We had positive 120. So the inverse of that would be subtracting by 120 to both sides of my equation. So we added, or this, when you have a positive, you're going to subtract to both sides. So in this example here, Harris, can you close the door? They're more loud, they are way louder than normal. So let's try example 1, solve equations by adding. So we have x minus 7 equals -4. X minus 7 equals -4. So since my -7 right here, I'm gonna have you do it after I'm done here. So I have a -7 right here because there's a minus sign right in front. So -7. So that means I need to add by 7, sorry, add by 7 right when I said it. I was like, oh darn. I have to add by 7 to both sides. All right. So Ellen, what's that going to give me as my finished product? Yep, it's going to give me +3. So I'm just going to write +3 right there. You don't have to write the positive sign. You could just write, whoops. Oh, undo? Okay, thank goodness. You could just write x equals 3, and that would be the correct answer. Okay, so, oh, and it wants me to graph it on a number line. Yay. You know how to do it. It's just more the process of, yay, I get to do this. Okay, it is. So we have, I'm just going to write 0, 1, 2, 3. So I just need to plot 3 on the number line because x equals 3. That's it. Yep, so that's all. If it wants you to graph it on a number line, that's all you're going to do. You're going to have your x equals 3 right there. And this will be important when we get into less than, greater than, less than or equal to and greater than or equal to. So that's when it'll become more important. So this is the introduction of that, because I think we're getting into that here pretty soon. Yeah. Okay. So the second part of that, so we just did example A. Example B is just working with decimals. So if you guys have, do you guys feel like you are okay with doing the decimals as well? Yeah. Yep. So letter B, I have negative 13.9 equals n minus 9.7. So Madeline, what's the first step I'm going to do right here to solve for n? So this one's a little bit different, because see, the n is over here. It's on the right side. I need to get n by itself. So my n, or my variable, is all by itself right here. So that means I need, or it's not by itself, it has a negative 9 with it. That means I need to get negative 9.7 onto the left side of my equation using inverse operations. So how would I do that, Ellen? How would I do that?
Oh,
Yes, I add 9.7 to both sides of my equation. And the reason I'm doing that is because negative 9.7 plus 9.7 is going to be 0. So that's the whole point, is I want there to be nothing left except for my unknown variable on one side of my equation. So negative 13.9 plus 9.7, I'm just going to do, since that's a little more challenging, I'm just going to do 13.9 minus 9.7. And since I flipped them like that, I have to remember I'm just going to put a negative sign there at the end, because my negative number is bigger than my positive number. Negative 13.9 is bigger than 9.7. So 9 minus 7 is 2. Bring down my decimal point. 3 and 9, I can't do that, so I'm going to borrow from the 1. So 13 minus 9, I'm going to have 4. So negative 4.2 would be my answer for n. Okay, negative 4.2 equals n. Does that make a little more sense, Madeline, how I'm solving for that? Okay, sweet. Sweet. Okay, so let's try, we got 2 more examples. Example 2, solve by subtracting. So we're doing the same thing here, except we're going to do the inverse operation of addition, which is subtraction. So my first example, I have, actually I'm going to do letter B because the decimals are harder. So we have m plus 6.7 equals 3.4. So m plus 6.7 equals 3.4. So Logan, how am I going to start this one off? Yeah, subtract by 6.7 to both sides. Good. Because I want m to be all by itself on the left side. So m would equal, so since my negative number is bigger, I'm going to do 6.7 minus 3.4. And since I flipped their signs, I need to make sure I add a negative right here. Okay, so always remember that negative, since my negative 6.7 is bigger than positive 3.4. And when you guys are doing these, I'm okay with checking yourself with a calculator, but make sure you do it first by hand and then check yourself with the calculator. So 6.7 minus 3.4, so 7 minus 4 is going to be 3. Add my decimal, and then 6 minus 3 is 3. So I have negative 3.3 equals m. Okay, so that's example 2. Let's do the real world problem, example 3. So example 3. So we're solving by subtracting. So this is a photo example, fancy. So Hiller is making digital scrapbooks as a gift or as gifts for her family. After saving her current work onto a CD, the CD is 5/6 full. If the CD was 1/3 full before she started saving, what fraction of the space on the CD do the new pages copy? So we don't really work with CDs anymore as much, but this is very relevant for phone storage or computer storage on your computer. Seeing what you can, seeing how much storage you can add onto your video game console, how much you have left. I always have to go through and delete certain games because I don't have very much memory on my gaming system. Yeah, Madeline.
I started writing it without even looking at it. Why do they want to make this so much?
Yeah. So my total is 5.6. And then it says there is 1/3 of the space is filled up, and I want to know what X is. So 5/6 is the total available space. 1/3 of it is already full, and I want to know how much I can fill up. So all this is just a subtraction problem. So minus 1/3 to both sides, because the opposite of +3 is -3. So that's gone. And I'm going to need to turn 1/3 into, bless you. I'm going to need to turn 1/3 into 3/6. Let's see, where's my eraser? There it is. Not 3/6, 2/6. 2/6. So all I did there was I multiplied both my numerator and denominator by 2. And when I do that, 5/6 minus 2/6 is going to be 3/6. So 3/6, or 1/2, or 1/2. Okay. That's how much is available for new pages. Okay. All right. So pre-algebra, keep chugging along on your guys' stuff.